So hello everyone, in this video we are going to discuss the problem sum of goodness. So in this problem we are given an array of size n and we have to find the total goodness of the all the subsequents that are formed from the array. Let us suppose we are given the array 10 3 2 5 11 3 1 and 12, and we pick up a subsequence like 3 2 5 3 and 1. Then what we have to do for finding the goodness, we have to sort that particular subsequence. After sorting this array, it will become 1 2 3 3 5, and the goodness will become all the numbers at which v of I is equal to I, because here in we can see 1 2 3 and 5, its starting index is 1, so all these are having same value as at their index, and this 5 also is having index 5 and value 5, so they will contribute in the goodness. So we have to find in particular this sequence the total goodness 6 4. So for all subsequences we have to find the total number of goodness after adding all the goodness of each subsequence. So moving on to the solution. So let us suppose we are having some random numbers like 5 4 1 2 10 7 3. Okay, so when we can see this problem in reverse order, like instead of seeing each subsequence the contribution to the goodness, we can see what contribution each element is giving to the all the subsequence formed, right? So if we choose this number in all the subsequence, so it will give contribution to the goodness only if it is having the position fifth in the subsequence after sorting. Clear? So for that, having the fifth place on this subsequence formed, it should have exactly 4 numbers less than it. Why? Because when it will have number 4's less than it, then it will be at the fifth position after sorting. I think you get some idea, and we didn't have any problem if it have or have not the numbers greater than it. Let us suppose we will take some examples like 3 3 2 5 5 and 3. Now for these three there should be at least two numbers which are less than it. Are there? No. For these two there should be at least one number which is less than it. Are there? No. For this 5 there should be at least 4 numbers which are less than it. There are only 3 numbers. For this 5 there should be at least 4 numbers which is less than it, so there are numbers, right? And for this 3 there should be at least 2 numbers which are less than it. There are, because these 2. Okay, and the we can see it clearly by after sorting it, so it will become 2 3 3 5 5. Now we know the index of each number, so we can get number of numbers smaller than it directly by seeing its index. So it should have at least one number less than it. So number of numbers less than it are its index only, so it's 0. So there should be at least v of I minus 1 numbers less than it. So number of numbers less than it are I, so number of numbers should be at least greater than equal to that number minus 1. This is first condition. to form a subsequence in which it will contribute to its goodness. So it is not forming. So these three should have at least two numbers less than it. It is having only one, so it will also not contribute in the goodness in any subsequence formed. Now these three, we can see there are two numbers which are less than it, right? So it will form a sequence in which it will be exactly at the third position, right? So how many this subsequence form, let's see. So we have to pick exactly two numbers less than it. So how many numbers are smaller than it? These are two. So we have to pick at exactly two numbers, right? And there can be anything after this number, because it doesn't matter how many numbers we take after it will always be at the third position, right? So total number of sequence, it will be 2c2 into 2 to the power the numbers after it to the power 2. So I will see why it has happened. So first sequence will be 2 2 3 and take nothing, though 2 3 3, and second sequence will be 2 3 3, take only 5, in the next take only this 5, in the next take both 5. So it will form exactly 2 to the power number of numbers greater than it, correct? I hope you get the idea for this number. So this was the contribution by these three. Okay, now for this 5 should have at least 4 numbers less than it. There are only 3 numbers. This 5 should have at least 4 numbers less than it. Yeah, there are 4 numbers less than it. So total contribution by this 5 will be, we have to pick exactly 4 numbers from these 4 numbers. So 4c4, and how many numbers are right to it? So 2 to the power 0. So total contribution will be addition of these two. 2c2 is 1, so 2 to the power 2, and 4c4 is 1, so 2 to the power 0, so it will be 5. Okay, let us take this example. It is very good example. See, 1 1 1 and 2. Okay, so their indices are 0 1 2 3, right? So we have to see it is having the condition is validating or not. I should be greater than equal to v of I minus 1. V of I minus 1 is 0 and I is 0, so it will form a sequence, and number of sequence will be 2 to the power 3, because 3 numbers are greater than it, plus this number is having, so we have to pick exactly 0 numbers from 0 numbers, it will be 0. We have to pick exactly 0 numbers from the 1 number, and numbers to the right of it is 2 to the power 2. Next we have to pick exactly 1 for this 1. We have to pick exactly 0 numbers from these 2, and to the right it will form 2 to the power 1 number of numbers, and for these 2 we have to pick exactly v of I minus 1, that is from these 3 we have to pick exactly v of I minus 1, that is 1 number, and it will form 2 to the power 0. So this will be total answer, that is 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 3, that is 8 plus 4 plus it is 1, 2 plus 3, that is 17. Okay, I hope you get the idea. So summarizing all this, I have make some notes. Yeah, so for each integer we have to calculate the contribution it is adding to the goodness of all the subsequences it is forming, right? What we were doing, we were finding for each number it is contributing to the goodness of the subsequence. we are thinking in the reverse order. That was the crux of the question, and this was very important, that there should be at least v of I minus 1 numbers to the left of it to form a valid subsequence, right? And the total contribution of this will be the product of exactly taking v of I minus 1 numbers from the left of it that are smaller than it, and the number of subsequence that are formed by taking or not taking number to the light. These were to the power n, where n denoting the numbers to the light, and the number of this value which is taking exactly v of I minus 1 numbers from all the numbers smaller than it is NCR, where n denotes the number of smaller number than v of I, and R denotes v of I minus 1. So moving on to the solution, there is something you must know. There are some pre-computation we have to do in this problem. I will show you the pre-computation afterwards. So I have taken the vector as input and sorted first, right? We have sorted at every time, and after sorting I have initialized a counter variable, and I am checking this condition whether there are at least v of I minus 1 number smaller than it or not. Then only it will form a valid subsequence, right? And then I am finding the number of subsequences by taking or not taking the numbers greater than it, and then I am finding NCR, that is I denotes the number of numbers less than it, and v of I minus 1, we have to take exactly v of I minus 1 numbers, and mod is 10 to the power 9 plus 7, right? And then I am adding the multiplication of these two values. Now for this NCR, we have to pre-compute the factorial before starting the test cases, right? So I have make the pre-function. It will just calculate all the factorials and store in it. It is a global variable, and this NCR will just return the NCR value in O of 1 time. So it will take just the power. So time complexity of calculating of power is log n, so its complexity is log n, its complexity also log n, so over of time complexity will be n log n. So that's why it is accepted solution. I hope you like it. Please subscribe to my channel and click the like button. Thank you so much.